Hi guys. First off, I just wanted to say I miss you and I hope you're doing well. Um, I know this activity this week was a little bit tough, especially that first one, but you guys rocked it in this next one, so I think we're gonna be all right. Um, with this activity that goes with this video, if you guys are okay answering the questions without watching the whole video, that's fine. This is just to kind of help you out. As it said in the introduction there, we're going to focus a lot on why. So the first thing we looked at was in standard form. We looked at what happens when A gets bigger. And you guys all um, pretty much told me that when A gets bigger, it gets skinnier or smaller in width, um, or it tightens curve, depending on however you want to think of it. But all of those are right. It goes from this guy to that skinny guy there. So the first question that I'm going to have you answer on the activity is, why did the graph shrink when A increased? And to help you kind of answer that, I want you to think of what would that number in front do mathematically. So you have a right next to the x squared. When two things are right next to each other, what do you do with those two numbers? You multiply. If you multiply by a bigger number, what's going to happen to your graph? Think on that. Give me your best answer for that one. So you can pause here and answer that. Okay, then the next thing we looked at is what happened when it got smaller and then negative. So you said it went from this upward parabola to that downward parabola. The way you can think of that is if A is positive, smiley face, it's positive. If it's negative, it's a frowning face. One person here, and a few of the others, but one that I grabbed here, also noted that it also gets wider first. And we're going to look at that a little bit more later on. But if it's like this, on its way to being negative, it's got to stretch out before it can flip over there. So kind of related to the last question, why did that negative make it flip? Okay, so you can pause and answer that quick. Okay, then we looked at B. And we noticed that B did something a little bit weird. It moved it the opposite of what you would probably expect. So when B was positive, when B got bigger, it moved it to the left and down. And when B was negative, it moved it to the right and down. So either way, it goes downward when B gets bigger, or sorry, when B changes. But it either moves to the left or to the right. B is a little weird. We're not going to focus a ton on B right now, but I do want you to make an educated guess. So you can pause here. Why do you think it moved like that? What mathematical stuff is going on that would make it do that? It's okay if you don't have a solid answer for this one. We're going to mostly focus on A and C, but I do want you to take a guess on B. You can pause and do that quick. Okay, so now for C. As you guys noticed, when you change C, if it got bigger, it went upward. And if it got smaller, it went downward. Sorry, facing the same way. And this person, a couple people, many people, also noted that that was the y-intercept. So the question that I want you to pause and answer here is, how do we know that that C value represents the y-intercept? Okay, while you're thinking on that, while you're typing on that, I'm going to pull up a graph here quick. Happy Earth Day, by the way, yesterday, 2 days ago. Happy Earth Day this week. So I'm just going to make one up here, 5x squared plus 3x plus 2. And I can see that my x-intercept is 2. So I'm actually going to answer question 5 now that you have some time to think about it. At the y-intercept, what's the x value there? It's 0. So if the x value is 0, if I plug in 0 for each of these here, I get 5 times 0 squared plus 3 times 0 plus 2. The x value at the y-intercept is always going to be 0. So no matter what this stuff is in front, it doesn't really matter. If I graphed another one that said 87x squared plus 42x plus 2, it still has that y-intercept of 0. Because 87 times 0 is 0, 42 times that is 0. Those all go away. Okay, so that kind of helps you answer those two questions. Going back to our activity here. One of the questions asks you to create a very wide parabola. So I have three that I picked out here. Many of you guys did an awesome job, but I just chose these three. And I want you to look at the equations. So this one is negative 0.5x squared plus 2. Oops, sorry. Wrong thing. Let me get back here. This one is negative 1/7 x minus 2 squared plus 2. And this last one is, they use sliders. Their A value was negative 0.0001, their B was 0, and their C was 5 million, it looks like. So if I wanted to write this as my own equation, putting that all together, it would be negative 0.00, I want to count zeros, 6 of them, 0.0001 x squared plus 0x, or 0, plus 500,000. Okay? So I'll go through those real quick one more time. What do they all have in common? This equation right here, this equation right here, and this equation right here. What do all three of those have in common that make it nice and wide there? Okay. So that is your next question to answer in the activity. So if you want to pause and do that, you can. Then we're going to talk about standard form. In standard form, I asked on this screen here, let me pull it up, screen 12. I asked you, what parts of the graph can we see in this equation here? And most of you guys said this 5 right here. As you can see in that graph, plus 5, some of you said the y-intercept, and some of you guys even said that that 6x you can kind of see, which we'll talk about here a little bit more in a sec. But the main thing that we're going to look at in standard form is, as you guys notice, the y-intercept. Why can we see that y-intercept in standard form? We just talked about that a little bit, but why is that? Why is standard form easiest to see the x-intercept, or the y-intercept, excuse me? So that's your next question. Take a minute and answer that. Okay, and then the next thing that I asked you was, let me get your version. If we look at that same thing in standard form, what can you usually easily see? And you guys said this -1 and this -5. So we're going to dive deep into that. The first thing that I want to ask you, though, on screen 9 there, is what is the y value at the x-intercepts? If I look at these x-intercepts, what's the y value there? Take a quick sec, answer that. Okay, now I'm going to answer this one for you too. The y value here is 0. If you look at, if I graphed any of these, this one doesn't have y-intercepts. We'll talk more about that next week. What do we do then? Let's say I have these two. The y-intercepts, the y value is 0. Sorry, the x-intercepts, the y value is 0. So then that kind of gets into the next question. Why can we find these x-intercepts in factored form? So you can answer that. And then the following question, why are they backwards? Like this has a, let me scroll a little bit better here. This has a +1 and a +5, but I see a -1 and a -5. Why are those backwards there? Okay, so that's your next question. And that is pretty much it for the video. Now that you have that though, I have 1, 2, 3, 4 more screens for you to try something out in the activity there. Just trying to get things to go through those 2 points. If all of this helps and you want to go back and get more practice, you can go back to Monday. That Monday activity was just kind of more an introductory, get you thinking. If you didn't feel super great about that, see if you feel better about it now. And if you still don't, let me know. I think that's it. But be in contact with me. Thank you guys for getting your work done. Many of you are doing a great job. I'm really proud of you. I know that this is crazy and tough, so way to stick with it. Have a great weekend, and I'll see you guys next week.